Good day, I'm Karel Tan. The purpose of this video is to explain the proof number 51 of the Pythagorean Theorem and how this proof, proves it. We will be explaining to you the concept of the proof and will also provide a possible example of application of this Pythagorean Theorem in Xavier School.
Let's recall that Pythagorean theorem is a square plus b square is equal to c square.
Originally, the figure is a square in which it has an area of b squared because the length and the width are both b since it's a square. Now, in this proof, the triangle is rotated 90 degrees around one of its corners such that the angle between the hypotenuse in two positions is right, like here, in which we have this and this. The resulting shape of area b squared is then dissected into two right triangles with side lengths c and c and b minus a and a plus b. The area is then c squared over 2 plus b minus a squared divided by 2. Like I said earlier, originally it was a square with the area of b squared and it was just rotated 90 degrees to become two triangles with this area. So it is still the same figure, just molded into a different shape. So we can say that the area of these two are the same. So we can say b squared equals c squared over 2 plus b squared minus a squared over 2. As I said earlier, the area of the two triangles is c squared over 2 plus b squared minus a squared over 2. This c squared over 2 is the area of this one triangle, right triangle, while this b squared minus a squared over 2 is the area of this right triangle. We need to recall that a plus b times b minus a would equal to this, b squared minus a squared. We also need to recall that to get an area of a triangle, it is base times height divided by 2. Now that we have established that the area of b squared is equal to c squared over 2 plus b squared minus a squared over 2, we now simplify. So first we remove the 2's by multiplying 2 to both sides. So we cancel both 2's and we are left with c squared plus b squared minus a squared equal to 2b squared. We continue to simplify by making all the variables are on one side. We do this by minusing both sides by 2b squared. With that we get c squared minus 2b squared plus b squared minus a squared equaling to 0. Now since I have no more space on the front, I will use the back. So we have c squared minus 2b squared plus b squared minus a squared equaling to 0. B squared can be minus. So we get c squared minus b squared minus b squared equaling to 0. Don't these look familiar? Remember that the Pythagorean theorem is c squared equaling to b squared plus a squared. We can do that too with this equation. We just have to add b squared and a squared to both sides. We'll get c squared equaling to b squared plus a squared. Hey, doesn't that look the same? This is the Pythagorean theorem. And this is proof 51. From this, we can conclude that the proof 51 really proves the Pythagorean theorem.
I am Steward Wong. Have you ever thought of this staircase becoming a ramp? What if one day Father Ari decides to make this a ramp? With the assumption that the height of this overpass is 15 feet and the walkway below is 20 feet long. How do you think the ramp will be? The walkway is 20 feet and the height of the overpass is 15 feet. The Pythagorean theorem is that c squared equal to a squared plus b squared. So this is question mark. 15 squares equal to 225. 20 squares equal to 400. 400 plus 225 equal to 625. Square root of 625 is equal to 25. So the question mark is equal to 25. With those being said, the engineers will make this ramp 25 feet long.
Based on this application, we can conclude that the Pythagorean theorem has many uses and can be applied to many construction projects, like our example of this ramp. It can be used by architects and construction workers and engineers to build various ramps and other kinds of inclines to use in different construction projects and works.